Welcome to the presentation on behavioral design patterns, focusing on the observer and strategy patterns. Let's dive into these crucial design patterns and explore how they help improve object interaction and flexibility in software design. Behavioral design patterns are all about how objects interact and communicate with each other. These patterns define the way objects should collaborate and share responsibilities, ensuring effective communication and interaction within the system. There are several behavioral patterns, with the observer and the strategy patterns being key examples. The observer pattern helps notify multiple objects when a change occurs, while the strategy pattern allows for selecting a specific algorithm at runtime. These patterns aim to simplify object interaction, ensuring better scalability and maintainability. The observer pattern is a design pattern where an object called the subject notifies its dependent objects known as observers whenever its state changes. Think of it like a news agency that notifies all its subscribers about breaking news events. This pattern is commonly used in notification and event handling systems. In the observer pattern, there are several key components. The subject, which maintains a list of observers and notifies them of any state changes. The observer, which defines an interface for receiving updates. The concrete subject, which implements the subject interface and sends updates. The concrete observer, which implements the observer interface and reacts to the updates. The workflow of the observer pattern involves three key steps: attach, update, react. Attach observes register themselves with the subject. Update, the subject changes its state and notifies all registered observers. React, observers receive the updates and perform necessary actions based on the new information. Here's a simple example. Consider a notification system where users subscribe to receive updates on stock prices or news events. When an event such as a price change occurs, all subscribers are automatically notified. This is the essence of the observer pattern. The strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. This pattern allows the algorithm to be selected at runtime based on the specific context. For example, in a payment system, a user can choose between different payment methods such as credit card, PayPal, or cryptocurrency. The strategy pattern consists of three main components: the strategy interface, which defines a family of algorithms; the concrete strategy, which implements a specific algorithm; the context, which maintains a reference to a strategy object and calls the algorithm defined by the strategy. The workflow of the strategy pattern involves three main steps. Set strategy. The context sets a specific strategy for its operation. Execute. The context delegates the execution of the strategy to the selected algorithm. Switch. The strategy can be dynamically switched based on the context, allowing flexibility in the system's behavior. Let's look at a real-world example: a payment system where users can choose from multiple payment methods such as credit card, PayPal, or cryptocurrency. At runtime, The user selects a strategy and the system processes the payment accordingly. This dynamic selection of strategies is the essence of the strategy pattern. In this exercise, our goal is to implement an observer pattern for a notification system. The task is to create a system where users can subscribe to notifications and receive updates whenever there's a change in the system state, such as an event or status update. Let's take a look at the code implementation of the observer pattern. First, we define the observer interface, which includes an update method that will be called when the subject's state changes. Similarly, we define the subject interface, which includes methods for adding, removing, and notifying observers. In the next part of the implementation, we define the concrete subject class, which implements the subject interface. The notification system class maintains a list of observers and notifies them when the state changes. It also includes a setMessage method to trigger the notifications. Now let's look at the concrete observer class. The user class implements the observer interface and reacts to the updates by printing a message when it receives a notification. In this case, the update method displays the received message on the console. Finally, in the main function, we test the notification system. Users Alice and Bob subscribe to notifications and receive a message when the system state changes. We also demonstrate how an observer can be removed from the system so it no longer receives updates. In conclusion, the observer pattern helps decouple the subject and observers, making it easy to add or remove observers dynamically. The strategy pattern, on the other hand, promotes flexibility by allowing algorithms to be switched at runtime, reducing conditional logic and encapsulating behavior in separate strategies. Thank you for your attention. I now open the floor for any questions you might have about the observer and strategy patterns or any related topics discussed today.